aerobic bacteria. This is a stir tank. This actually is the same one as I show you in the photo, but the scale can be even bigger, higher. So here is the motor connected to an agitator. We'll mix the cell in the cell suspension. The baffle showing here is what I mentioned from my earlier photo, which will help the mixing and also increase the dissolved oxygen in the culture. In addition to the oxygen probe that I mentioned to monitor the oxygen concentration, the agitator will actually increase or decrease the spin according to the dissolved oxygen. Okay, so actually are connected. Okay, so there's also a pH probe, as you can see here. The pH probe used to maintain the pH within a range. If the pH changed during the fermentation, there's a controller connected to a base as well as acid solutions to control the feeding of the base or acids into the fermenter, therefore to help to maintain the pH setting. Okay, and as for the temperature probe, it's also connected to the controller. If the temperature increase, the cooling water actually helps to maintain the temperature. Normally, it's a double jacket glass vessel, okay, with the cooling water surrounded the fermenter vessel. Or some of the cooling water is only on the bottom, but the efficiency is not as good as the double jacket glass vessel showing here. Okay. In addition to a stir tank, there's also other way, such as airlift or fixed bed stir tank, but it depends on how they put the cell or how they supply the air. So basically, the idea is similar. If you want to continue to grow the cell in a fermenter, we can continuously feeding the cell with fresh media. In the meantime, removed spent media and keep the cell in the reactor using a filter or membrane. Okay, so what the design is, there's a label control here to control the level of the complete cultural suspension. So with the fluid from the fresh media gets in, some of the suspension will overflow through this label. With the filter, setting here, the filter will be harvested as a product, and the cell produced products such as protein will be continuous harvest through the filtration. So this is the perfusion device to couple a stir tank bioreactor to conduct a continuous culture using fermenter. As for the anaerobic bacterial cultivation, the bacteria need to inoculate and incubate in a equipment called anaerobic chamber and incubator. The anaerobic chamber is important for cultivate the anaerobic bacteria, such as you have isolated bacteria from the gut, from the feces, or from the deep pocket in under your teeth. So the anaerobic chamber, the gas in the chamber, this is a representative, typical percentage is 10% hydrogen, 10% carbon dioxide, 80% nitrogen. To remove the trace oxygen part, PD is a catalyst to catalyze the formation of the water from hydrogen and oxygen, and therefore to keep the trace amount of oxygen goes through the system. As you can see here, there's a small chamber here to allow you to put your stuff here for a while, and then open the chamber here by using this to control the inside the gas. Okay, there's like a two-way of getting to these anaerobic conditions. The anaerobic chamber will maintain positive pressure to prevent the oxygen from the environment gets into the system. And we also want to make sure the temperature is kept evenly distributed, because after the inoculation, we still use this chamber as an incubator. We leave our plates or tubes inside the chamber, so we hope that the temperature is well controlled. If you do not have an aerobic chamber, and then you can use an aerobic jar or bag. Okay, so there's some catalyst inside to remove the oxygen. It's also workable. Then you can move the jar into the incubator with a different setup of the temperature. So you still can take the